The next two speakers, we're going to concentrate on that last topic that Sean was talking about, which is biochar. And it's a new area for the association. Well, it's probably about 5 years working at it now, but it's something where we see a lot of development happening. So our first speaker is Kathleen Draper. Kathleen is the chair of the International Biochar Initiative, and she's focused her work there in education, research and consulting. She has designed and hosted IrBEA's first Biochar Academy, and generally works in the area looking at new material use such as composites for buildings, packaging materials, and as well as for soil use. So Kathleen, I'll invite you to take the stage. Thank you.
Yeah. Well, thank you first off for the invitation to come and speak. I did want to ask how many people have heard of biochar already? Oh, pretty good. And how many are actually working in biochar? Not quite so many. Okay. Well, they did ask me, just in case there were people here that had not heard of it, to cover it at a very high level, so I'll do that. I'll also talk a little bit about what you can use, what is being used to make biochar, how it's being made, how it relates to this whole topic of bioenergy, and I'll talk a little bit about what you can do with the biochar, and very, very briefly, I'll talk about the whole carbon dioxide removal marketplace and what that's done to the biochar industry. So I tend to talk about biochar at two different levels, and to invoke, I think it was Fergus who talked to his mother about it. When I talk to my mother about biochar, I use the analogy of burnt toast, because otherwise she gets a little flustered. But basically all you're doing is taking some kind of organic matter, putting it in an oxygen-deprived environment, think of a stove, cranking up the heat, burning off the water and some of the other volatiles, and you get this very unappetizing looking carbon, which we probably wouldn't want to eat that, and it's the same thing with soil microbes. They do not view it as a food source. So what you're really doing here is disrupting the carbon cycle. So up to 50% of that carbon that was in the original biomass is converted from a short-term carbon, which will go back into the atmosphere as carbon dioxide, into a stable, long-lasting carbon. And there's all sorts of discussions about how long it will actually last. And my standard answer is, it depends. It depends on the feedstock, how hot you cooked it, and things like that. But research has shown, and history has shown, that it can last for hundreds, if not thousands, of years. The other way I like to describe it is slightly more sophisticated, but hopefully not overwhelming, is in terms of its most common carbon cousins. And everybody knows what charcoal is. A lot of people know what activated carbon is, and probably 98% of the people I talk to have never heard of biochar, but they all look very, very similar. But there are some distinct differences, not least of which is the carbon footprint. So starting from the bottom there, biochar is one of the very few negative emissions technologies recognized by the IPCC. It isn't always actually carbon negative. It really depends on how energy intensive the process is, but in general, it is sequestering more energy or carbon than it takes to make it. As opposed to charcoal, which can be at best a carbon neutral process, but we know in some parts of the world that the charcoal they're using is leading to deforestation and things like that. And on the other hand, we have this activated carbon product, which is very energy intensive, and so it is carbon positive. The things you can make it with, which I'm going to touch on in the next slide, for biochar are a lot broader than what is traditionally used to make either charcoal or activated carbon. And that leads to, as I think one of our earlier speakers said, a wide variety of biochars. I think one of the issues that we have in the biochar industry is that it all looks the same, but it's very different, chemically, physically, electromagnetically. And what we're seeing now in the biochar world has for the last 12 years really been focusing on agriculture as an end use. And as many of you probably know, that's a fairly risk-averse industry to go after, and biochar in its early stages has been pretty expensive. So we've struggled, to be honest, to get farmers to adopt it as a soil amendment. And that's why we're starting to see it lead into more of the traditional activated carbon markets, such as filtration, remediation. But in the last, say, 3 years, I would say, we're really starting to see it move into newer markets, such as concrete, asphalt, other building materials. So it's been a really exciting industry to be in, from my perspective. The cost, everybody wants to know how much is it. Well, it goes anywhere from zero, literally, to $2,000 a ton, and I'll go into that a little bit more in a second. So what can you make it from? This was actually done by a group in Denmark. This is not comprehensive, but it's just shows you how wide the range of materials can be. Right now, the most used feedstock is wood, at least in Europe and the US. I would say in places in like China or most of Asia, you're seeing crop residues such as rice straw, rice husk, being converted into biochar. They make very different biochars, but we're starting to see a lot more crop residues in play. We're also starting to see manure, livestock manure, poultry, dairy, swine turned into biochar, mostly as a waste management play. And even more recently, we're starting to see sewage sludge being carbonized. And again, they're very focused on volume minimization, but also things like PFAS mitigation, which can be handled in the pyrolysis process. So depending on whether you're being paid to take this feedstock, which is sometimes the case for, what's almost always the case for sewage sludge, but it can be the case for other residues, or whether you are paying for it, which is the case with most wood residues. And the price for those wood residues has doubled or tripled, at least in some parts of Europe, in the last 2 years since the Ukraine war, can have a serious impact on how much you need to get for the biochar. And as I mentioned, the type of biochar you're going to get and what the optimal end use is going to be is largely dependent on what you're using to make the biochar, how hot you're cooking it, and what your other processing parameters are. The process of making biochar has been happening for thousands of years around the world in many different indigenous communities. Nowadays, we're making it with a lot higher technology. But I have a couple of examples here. This hole in the ground, I was teaching coffee farmers in Colombia how to make biochar from their coffee stumps. They stump the trees every 5 or 6 years to regenerate them, and they let them pretty much revert to carbon dioxide. So we were showing them how they could turn that particular kind of biomass into biochar and then use it after they've added some type of nutrient as a slow release fertilizer. A friend of mine in upstate New York, where I'm from, she and I tried to do a controlled burn with their biomass that was left over after they pulled up the vines. And this is steam, it's not really pollution, but these are increasingly common ways for farmers to turn at least some of their residues into biochar. And you might get about a 10% yield by volume doing it this way. You'll get a much higher rate if you use more industrialized equipment. These kilns, they're called flame cap kilns. These are quite popular. There are thousands of them around the world. It's the same concept as this hole in the ground. And it basically is a batch system that allows you to make any kind of loose biomass into biochar with a yield rate of maybe 20%. And then this green thing in the middle is something that the US Forest Service has been using to take into the forest that need to be thinned, or after they've had fires and they have a lot of standing dead trees. These particular kind of machines, you can effectively cut the tree, chop it up into cookies, and they used to incinerate, but now they're optimizing these machines to make biochar. Again, it's not the highest yield. You're not able to use the energy, but it is a great way to minimize fire risk. On a more industrial scale, you'll see on the bottom left here, I just took a group of about 80 people to this bioenergy plant in Switzerland. It's probably a $40 or $50 million plant that uses the electricity generated from the wood biomass in a sugar mill across the street. They use the heat in the district heating system, and they produce anywhere from 5 to 15% of biochar, depending on the demand for the biochar and the heat energy. The one with the red door is also a unit. It's made from France, but it was in Switzerland. It's being used as a sawmill. They use the excess heat to help drying the lumber for the other part of their business, and then they're using the biochar. In this case, they are putting it in concrete to develop a carbon neutral or carbon negative concrete. And then the orange one here is also, this is a farm scale machine where it's basically what they call a top lit updraft batch machine. You fill it with wood chips, you push it under this black chimney, you get the heat, which is sufficient to heat the house. And then when it's done, when it's burned down to almost the bottom, you'll get the biochar out of that. And then the other one is a bioenergy unit mostly focused on biofuels in Iowa. This is one of the X Prize winners, but they do get a substantial amount of biochar as well. In the last couple of weeks, I've listened to two different people that are in the biochar world, and they are retrofitting bioenergy plants to optimize the amount of biochar that can be produced. And I had no idea what that opportunity looked like, but my friend from Pacific Biochar was saying globally there's more than 4,000 of these bioenergy plants out there that could be retrofit to also make biochar. And they're financing that completely on the carbon credits related to the biochar. And another biomass producer in Canada, KMG Energy, gave a talk a few weeks ago saying that the cost of doing this as compared to a greenfield is 80% cheaper or more, and you can retrofit in about 4 to 5 months as opposed to 1 to 4 years, which it would take to create one from scratch. So I think this represents a really interesting opportunity. I'm happy to put anybody that's interested in that in touch with these two different folks that are working in that area. So I actually work in the world of what to do with that biochar, and I created this chart many years ago. It's very out of date, but it serves a purpose. And what it's looking at were potential markets for biochar and what the volume might be in those different markets, what the price you might get for the biochar, and how ready was it. And I missed a lot of the markets. As an example, compost is the #1 buyer of biochar in the US right now. The reason they're buying it is because it solves some of their problems. Mainly right now, one of their biggest inputs is horse manure or any kind of manure, which has a lot of herbicides and pesticides in it, and it wasn't getting dealt with during the composting process. So they were getting a lot of pushback from buyers saying it's killing my plants. So they put a lot of money into researching the co-composting of compost and biochar, and they found that it was able to mitigate this problem. One reason might be that it helps get the compost hotter, but it's also going to sorb any remaining herbicides and pesticides. So they're a believer. We're also seeing the stormwater management industry become very interested in biochar because it can hold 4 to 5 times its weight in water. And anaerobic digestion. There's a lot of synergies with anaerobic digestion and pyrolysis. I would recommend co-location of them because oftentimes you have a lack of a market for the digestate. You can use that as your feedstock for biochar. You can put the biochar back in the digester to increase the quality and the quantity of your methane. And then there's things like in the livestock industry, putting it in your bedding first as a way to absorb some of that excess nutrient, and that's how it might get into your digester. So, and this, first time I went through this biochar market study, I completely said carbon offsets aren't really going to help because at the time they were about $5 per ton. I'm going to touch on the last slide how that's changed, and it's changed the biochar industry incredibly. But what we really need, because this is one of the biggest sticking points for biochar right now, are large, repeatable, non-seasonal, economically viable and legal applications. Again, with targeting farmers, the value proposition can be challenging, especially with annual crops where you're not getting a lot of profit per acre or hectare. We're seeing a lot of uptake in perennial crops, especially those where they have a long drought, because it'll help with water management. And the market for biochar as a feed additive is not quite legal in the US yet. What that does is the same thing it does as if you go to the hospital and you have ingested something toxic, they'll give you activated carbon to get rid of that. So with animals, it's ejecting some of that herbicide or pesticide that's causing health problems, and it's delivering that charcoal or biochar to the land to help improve the fertility of the land. I don't know what my timing is here, but I want to just talk a little bit about some of the non-ag uses. So I brought some samples. One of the universities I work with near me in the Rochester, New York area is putting it in biofilms. And these are used by farmers for weed suppressant and to help heat up the soils. But what they're doing, instead of using carbon black, which isn't really great for soils, it's made from fossil fuels, they're using a binder that's biodegradable. So after the harvest, they will spray something on to degrade that binder, and then the biochar will just be left in the field, which is nice. There's not tons of biochar in there. There's another company in Saudi Arabia that is carbonizing their poultry litter, and they are putting biochar in some of their packaging materials. It's a food company, but they're also using it within the poultry barns to help lift up the small chicks so that they're away from some of the dust and dirt. And then there are other things that you can do with it. In Korea, there's a company that's putting it in flooring. Obviously, you have to like black flooring. There's companies that are trying to, sorry, I have it all too well packed in here, but there's companies blending it with plastics to make a kind of plastic lumber for flooring and other sort of exterior use flooring. I myself was just on a project a year or two ago putting it in drywall, and we did a techno-economic analysis on, the viability. What you're displacing there is fairly low cost. It's gypsum, so it wasn't going to be economical to buy it and ship it to the drywall manufacturer. But when we spoke to a huge global company, they were sort of moderately interested, but when we said, look, you could use in-house biochar production and use that heat to displace your scope 2 emissions for drying the drywall or the calcination process, then they got very interested. They now have a global team looking at how to do this in all of their subsidiaries. So I think this is an exciting area, not just on the biochar side, but when you can incorporate it with those big industrial users that need heat. So not that I have any real depth of knowledge about Ireland and how biochar can help, but I did work on a paper a couple of years ago with Cornell University where we looked at biochar production and use in dairy farming, and I hear that's quite a big industry. So we saw that there were a number of different ways that it can help, not least of which is the anaerobic digestion that I've mentioned, but also in things like if you are just composting your manure, if you co-compost that, it can reduce methane emissions by 80% or more, which is, I think we really need to focus on methane a lot these days. Biochar also doesn't tend to have any nitrogen that gets burned off in the pyrolysis process, but it is good at harvesting nitrogen, and I somewhere read that you have a lot of excess nitrogen in your water bodies. So sinking biochar around water bodies can help. Putting booms of biochar in water bodies can help. I was just on a small farm that had ponds in another part of New York State, and they had a very simple system where they were filtering the water from the pond through the biochar as a way of, getting it out of the pond, but also enriching the biochar with nitrogen that they could then use on their fields later. And I have read minimally about peatland restoration, and I think biochar may be able to help, although in a conversation last night I heard the current restoration process is far more focused on just flooding fields and things like that. So I just want to speak briefly about the impact that the carbon dioxide removal marketplace has had on biochar, because our next speaker knows far more than I do. But the first instance of a biochar methodology was in 2019 by a company called Puro, which is now majority owned by the NASDAQ. And it really, really changed the industry almost overnight. We now have 3 and soon to be 4 biochar methodologies. So Pura was one, the European Biochar Consortium is one, Vera just came out with one last year, and then the Climate Action Reserve is coming out with one soon. And as I said, it's changed everything. Venture capitalists are interested now, and companies like Microsoft are buying it. And the average price for the carbon dioxide removal equivalent for biochar purchases is $180 per ton. And when you convert that back into biochar, it's double or triple that, depending on the carbon efficiency of the process. So that's changed the whole game, and it allows us to sell biochar for a lower price, which is really what we need. Just flag me when I'm so yeah, that's really helped. On the other hand, you cannot get the biochar removal credits until you've sold the biochar for a carbon preserving use. And our biggest competition right now, if you want to call it that, is selling it to the steel industry as a fuel, which is good in one sense. They're trying to decarbonize away from coal. And so it's better, it's carbon neutral possibly, but it's not really slowing down the carbon cycle by much. And in the last year or so, we've seen this whole notion of carbon dioxide removals focus heavily on what they call durability, and they really want 1,000 years. And as I mentioned in the beginning, biochar durability can vary. We know it's usually 100 years or more, but when buyers are really focused on 1,000 years, you know, we have a higher standard. We like to focus their attention more on all the co-benefits, but that's taking some convincing. Yeah, and so it's had a huge impact. We don't know how long that price is going to stay that high. We think it'll probably settle around $100. Right now, there's only probably 3 dozen buyers buying it at that price, and we need a lot more to support scaling the industry. The price of the biochar, as I said, is extremely variable, depending on many things, not least of which is what are you using it for and what are you displacing and how much does that cost. So I think we're going to see a lot lower prices in general, so we need to get the business economics of the production side to work. Yeah. I'm here for tonight and tomorrow. If anybody has any questions, I'm happy to chat.
Thank you very much, Kathleen. It's very interesting to see the background to where the research is going and where it can actually, what we can achieve with biochar.